Good evening, students. Uh, this session is dedicated to the doubt asked by a student in last revision class for digital electronics. So the problem is associated with shift register concept. Okay, so I'll show you, I'll tell you the question first and then we'll see the solution part. Okay, so this question is also in question bank. So I told you all that I'll share the solution for this. So this is the question. Okay, so here let's go through the question. So the question is that the content of a 4-bit register is initially 1011. The register is shifted 7 times to the right with the serial input being 1010110. So what is the content of the register after each shift? Okay, so here we can start the solution part for this question. So, but before that, we must understand the concept. Okay, so you can see here a few of the important points that we have to consider here. So they are, first one is this 4-bit register. Okay, so this is first thing that we have to keep in mind. Okay, and then we have this serial input. Okay, so when we talk about 4-bit register, that means we need 4 flip-flops. Okay, so we'll try to understand this problem in terms of 4D flip-flops. Okay, where we know that we have a input signal. Okay, for example, this is D, and this obviously is my clock signal. Okay, so I'll make these 4 flip-flops. Okay, so the output of this will act as input for this second one. Okay, and the output of second is input for the third one, and output for third is input for the fourth one. And this is my final output. Okay, so as they have mentioned, so this is my serial input. And obviously, this is my serial output. Okay, so this is the clock part. So it will go like this, each and every flip-flop. Okay, because we know that one flip-flop will have 1 bit of data. So if it is 4-bit register, so 4 flip-flops we need. Okay, so we are using 4D flip-flops to understand this. Okay, now what is the given value? We'll write it here. So initially the content is it is 1011. Okay, sorry. So you can see here the register is shifted 7 times to the right with the serial input being 1010110. That means we have to serially input the values in these registers, okay, in this register 7 times, and we have to see and analyze like what should be the value at each shift. Okay, and that too we are talking in terms of right shift. Okay, so there will be change in this part, like it is now it is 1011, so it can be 1100 or 4 times 1 or 1 or 1110 or 0111, anything it can be. We'll see this. So initial condition here, I'll use a different color so that you can understand this. Okay, so this is my 1 this is 0, this is again 1, and this is 1. So this is the part that I'm talking about. So these are the initial content of my individual flip-flops when we talk in general about the shift register. Okay, and this is clock. Okay, so now if you look for this particular question, so serial input is given as 10101110. Okay, so now what we'll do, so we all know that this is my most significant bit and this is my least significant bit. So I will enter the data from least significant bit to the most significant bit. That means first 0 will get entered here, and then 1, then this one, then this 0, 1, 0, 1. Okay, so this way we have to move. So the order in which we'll enter the data would be reverse in sense 0, 11, 0, 1, 0, 1. Okay, so we'll enter as per this format, like from least significant to most significant. Okay, so this is where we are we are making sure that we are doing the right shift here. Okay, so the first bit is 0. So what will happen? This 0 will come at this place. So I'll change the color. Okay, so this is the 0 that we are talking about. Okay, so this 0 came over here. This 1 will be shifted to this place. So this is the 1. This 0 again will be coming over here. And this 1 will be coming over here. Okay, so this is the first step when we entered this value of 0. So if you look at this blue bits, so it is showing as 0, 1, 0, 1. Okay, so you can see here initially it was 1, 0, 1, 1. After first shift, my value is 0, 1, 0, 1. Okay, now what we'll do it for this one. Okay. We'll do it for this one. So what will happen? This one will go over this place. Okay, you can see here it is right shift. From here it is going to this, then this, then this. So this way right shift. Okay, so this one will go at this place. I'm marking this in green color. Okay, so this 0 will come over here. This one will come over here, and this 0 will come over here. So now in second shift, my value is 1, 0, 1, 0. Okay, let's talk about the third one. After that, I'll tell you how to generalize that. So when you talk about the third part, okay, this one, okay, so this one will be here. So obviously this one will go here, okay, and this 0 will come over here, and this one will come over. Okay, so whatever is marked in pink, that is the third shift. So what is that number? That number corresponds to 1, 1, 0, and 1. Okay, so till now, these are the three shifts that we saw. Okay, like how we entered the value. So we have to do this for 7 number of times. Okay, so for fourth shift, I'll tell you a shortcut, or like after doing this, how you can correlate the other steps. Okay, now we have to enter 0. Okay, so now we are talking about this 0. So what will happen? You will put 0 at the first place. Okay, and you will shift the other numbers to the right. That means 0 is at first place. After that, you will put 1, 1, 0. So you can see here 1, 1, 0. Okay, you put this 0 at this first place of third shift, and then you shifted these three numbers to the right. So these three numbers were 1, 1, 0. So this is 1, 1, 0, 0 at its first place. Now, similarly, again, when we talk about the fifth step or the fifth shift, okay, so this one we have to enter. Okay, so what will happen? This one will replace this 0, and this 3 bits will be shifted to the right after this. That means it is 0, 1, 1. Okay, so 0, 1, 1. Similarly, let's talk about the sixth shift. Okay, so we already used this also. So again 0 we have. So 0 will be at the first place, and then 1, 0, 1. So 1, 0, 1. Now finally the seventh step. Okay, so we have, so this is also done now. So last step, this one, so we'll make it as 1, and after that this 0, 1, 0. Okay, so they are shifting towards right. So 0, 1, 0, 0, 1, 0. So looking at this, okay, you started with your initial content of 1011. Okay, and now you have 0101. Okay, so the final answer, how you can write it as, okay, so I need this page. Okay, so for that I'll write the answer here itself. Okay, if I'll go to this page now, it will go. So what we can do, we can write the solution here. So final answer, you can write it as, okay, so my initial content was 1011. From that, okay, I got values as 01, 01, 1010, 1101, 0110, 1011, 0101, and finally 1010. Okay, so this way the initial value, when serial input is being given individually, you have to put the values. You have to start from the least significant bit, and you have seen like how exactly you will transfer the values. And once you have done it for 3 bits or 3 shifts, after that you can correlate that you have to use the bits at first place and shift the other remaining 3 bits towards right. Okay, so if you will watch this video, okay, and you will see this carefully, you will understand this particular question. Okay, so this was a question asked in second revision class, and I used a different concept while explaining, and that was not correct. But again, I like saw this and try to solve this problem, and I'm sharing this one. So I'm sharing this one and one more like first revision class, that recording. So you can see this both as reference. Okay, just you can quickly go through that. Okay, and for this question you can use this concept to solve. Okay, other than this, please use your question bank as reference, and almost every topic is covered in that. So study well and perform good in exam. Okay, so all the best from my side. Thank you, all of you.